here's what's going on. We're trying to find the cosine of the sum of two angles. And there's the identity that you're going to use right there. The cosine of x plus y equals cosine of x cosine y. Plus signs on top, so over here, it's the corresponding sign is the minus. Minus sine x sine y. Here's what that looks like in terms of a and b. So what we have to do, we already know the cosine of a and the cosine of b. Somehow we have to find the sine of a and the sine of b. You could use this identity right here instead of drawing a little diagram and plug in these numbers for cosine and solve that identity for sine. I like to draw a little diagram, and you're doing the same thing. If angle A is in the second quadrant, you can picture that the cosine of that angle is -4 for this x coordinate right here over the hypotenuse, 85. So we need to use the Pythagorean theorem, which is the same as this identity right here. 84 squared plus y sub 1 squared equals 85 squared. You end up getting the square root of 85 squared minus -84 squared. That turns out to be 13. So once you know y sub 1 is equal to 13, then the sine of angle A is 13/85. That's one of the pieces of info we needed in order to use this identity. And over here for angle B is in the first quadrant. Drop a perpendicular from that terminal side to the x-axis. The cosine of that angle is 60 over 61. Again, adjacent over hypotenuse. Solve for y sub 2 using the Pythagorean theorem or identity 6, and you get 11/61. Over here is what y sub 2 is, 11. So sine is 11 over 61. So now we're ready to plug in those numbers into this identity right here. Cosine of A, cosine of B, minus sine of A, sine of B. If you use a calculator to do that and represent it as a fraction, this is what you get. -5,183 over 5,185. Now on board 2, I'll show you a slightly different way to do it for confirmation. If theta sub 1 is the and we could think of this as angle A in our problem, is the inverse cosine of -84/85. And for negative values, the inverse cosine function gives you a second quadrant angle. This is a radian answer right here. And theta sub 2, inverse cosine of a positive angle, gives you a first quadrant angle. So we don't have to make any adjustments on theta 1, theta 2. And if I take the cosine of the sum of those two angles, I get the same exact answer. Okay. There you go. Hope that helped. If you have any questions, post a comment.